Okay, so let's go to the point because we don't have much time. So I'll be really fast so that we have some time for questions. Okay, uh, let's start from introducing ourselves a little bit. We are a 15 years old company. We are working now with 9 different types of manufacturers of rolling stock, and we have what we call the digitalization platform called Savannah. And but regarding this presentation, we will talk just about the small piece of it that is the condition-based maintenance and the maintenance tools that we provide in it. Okay. So, well, what are the pains about the maintenance? You already know that the breakdowns, which therefore stop services, multiple types of manufacturers. Any operator has not even one, but 2, 3, or 4 or 5 different manufacturers or different series of trains, and also the limitations about the time for the maintenance. Like you cannot make a maintenance on the night time, or during cold hours. It's even worse than that. So the goals about the CDM strategy that we are working with is to improve availability, which is quite obvious, streamline resources, and reduce maintenance costs, which is I think it's the main point. So as I told, everything it's within Savannah, which is digitalization platform, which is a 24/7 web-based platform and 100% customizable and scalable. And it's meant to be for automatizing processes to improve decision making, etc. So about maintenance tools, which is the topic of this presentation, we've developed some quality parameters and analytics into the platform, to have that condition monitoring, but not also like the condition, but also these key KPIs, these performance quality parameters that determine that one asset is in a good shape or in a bad shape, in order to improve the resources, improve the decision making about how we streamline this maintenance over the units. We create reporting, alarms, and work order generation, automated maintenance planning, etc. So this is how we understand condition-based maintenance. Okay, so what we did basically is that we merged what is a CMMS and the monitoring platform, the condition monitoring platform that we already had. So we merged them all, and we created this thing, what we call it condition-based maintenance. Actually, it's our way to interpret or to understand the CBM. Okay, so just use your resources where the impact is high. Okay, if I have 100 people, where do I put these people that the availability after the maintenance that these guys are able to do increases at the most. Okay, so the concept it's quite easy. Okay, we gather the data that it's already in the exploitation, like the data about the operations, data about the mileage, data that it's in the ERP or wherever, the data that comes from the monitoring devices that we have. Some of them are our own devices that we provide into the platform. Sometimes there are devices that are already in the operator because they made some monitoring projects, or maybe they want to include some monitoring devices from third parties, and also the the resources, which is the third leg. And then we put constraints in it. And through these constraints, we build with the automatic preventive planner and the corrective orders. Okay. And these, the fitting that we put into the system it's very basic. Okay. On the first term, we use the preventive triggers, like the mileage of the units. These are real screens of Savannah. Okay. So like the mileage of all the units regarding all the types of maintenance that needs to be fulfilled, and also some corrective triggers, like something very obvious, like sorry about the now the like software auto check about the subsystems on the units, or also analogic information like the condition of the bearings, of the wheels, of the doors, of the pantographs, of the HVACs, of the compressors, whatever. Okay, and then these corrective can create these work orders that go to the planner. Okay, and finally the condition monitoring, which is the the good point. That's the reason why it's called condition-based maintenance, right? So this condition monitoring is based on the analysis of these assets, analysis of the data that comes from the devices that monitor these assets, or the usage of these assets, like the counters that we have, like how many times the doors have been opened, closed, how many times the pantry rack has been raised, how many times it's been working, the HVAC after the last cleaning of the last maintenance, whatever. Okay, so we give a qualification for any of those assets, and having that qualification, then we can make the whole mix. So we fit the system, and then we put constraints like, you know, maintenance cycles, depot availability, tasks dependency, execution time, and you know, what the calendar constraints, like the operation plan, the working calendars, the resources that we have. Okay, and with that we make the whole puzzle, and we create what is the CBM, or the automated planner. Okay, and we take into account like which are the turns that you may have for do that maintenance, which are the trucks available, which dependencies are there between some, you know, the different maintenance that needs to be done, and everything it's fully automatic. So every day it creates the next day, or the, you know, in a 10-day, 30-day, 40 days in advance maintenance planning that needs to be fulfilled. Okay, and that puzzle, it's built in a way that we ensure that the resources used in that maintenance will increase at the most, you know, the availability of those assets. And to gild the lily, what we're working now, because you know, we went from our first stage to, you know, to create the condition monitoring and have that qualifications of the assets. Then we made that integration with the ERPs to have the primitive information, and then we started to create that corrective triggers, you know, because we were working like a you know, a predictive system that we were creating, you know, predictions about when is this door about going to break, if the wheels are in a good condition or a bad condition, you know, these kind of things. And then we wanted to, you know, make another layer. Okay, so gild lily and make it more complex. So basically what we're working on now is that, okay, we have some maintenance cycles that are the maintenance cycles that all the operators have, that they negotiated with the manufacturer of the trains. But what we're doing now is that we are splitting them in all the tasks that need to be done in this particular maintenance. And these tasks, what we're doing is that we categorize them in three main you know, sorts. You know, availability, security, and static. Static is also static, and also the, you know, cleaning. Okay, so once we've got it all mixed, what we can do now is to create the puzzle with more complexity. Okay, not just with the constraint about these different types of maintenance that are or very strict on what it needs to be done, because, you know, there's just sometimes a security aspect involved in that, but also, you know, having all these small pieces. So the puzzle is more complex, and we can activate the CBM, and in some cases we can extend the time between preventives, because, you know, sometimes most of the tasks are not related to security. Then we can extend the time between those preventives, and because of that, have a cost reducer. Okay, that is it's one of the hardest parts to work with, because, you know, the maintenance on a rolling stock, it's quite more complex than in a signaling system. We've been working with signaling system CVM for a long time ago, but for the rolling stock, the thing is that there are so many security involved tasks that need to be done, or at least the manufacturers says that it's hard to, you know, change the maintenance plan. So if you don't split it that way, the cost reduction or the cost effective that the system could be, it's slower. Okay, so that's the reason why we are working that way. Okay, and these are the advantages about the CBM that everyone knows. I'm sure you all already know. So you know, we can automatize planning processes. So it means that you don't need one person that is is making the puzzle by hand, so it's fully automatic, taking into account the constraints that he may have whenever he builds it, and also the condition, the real condition of the assets. Then we can improve availability, streamline resources, and also track the condition, what is condition monitoring about. And for some more information, if you want to scan this, you have like the whole thing. You will see all the features related to digitalization of fleet, what we call digital train, which is a piece within Savannah. Actually, Savannah is a digitalization platform for all the operation. I mean, not only for the trains, but also for the infrastructure, for the signaling, for the operation, for many things. But here you will find the brochure about digital train, which is everything related to the to the rolling stock. And thank you very much. Sorry for speaking so fast, but I wanted to leave some time for the questions. So I guess now it's time for some questions.
Yes, indeed. Thank you for that session. I think let's just check the question panel. We do have questions. Where does the platform get its data from? Is it only from the smart motors monitoring devices or elsewhere? No,
as I said, the platform is meant to be very inclusive. So what happened is that whenever we started with a new customer, a new client, we install our platform, we install our devices for monitoring. But then they say, well, what happened is that I have a lot of different devices to monitor different things that they have their own screen, their own interface, and I just want to have one. And the thing is that if you want to go into a CBM strategy, you need to have all the information in the one place. So that's the reason why Savannah is an integration platform. So the information comes from everywhere that it's needed. Okay, so might be some devices that are our own devices, like track circuit monitoring, but maybe also devices that are from competitors that we also integrate into Savannah, because it makes it a better platform. More questions?
No more questions.
Okay.
Oh, actually, yeah. And yeah, quite a direct question. What is the payback of Savannah?
Well, that's a good question. Actually, Savannah is meant to be platform as a service. Okay, so it means that there is no investment. It's an OpEx model. So since our business model is to make long-term relationships with our customers. Okay, so we are meant to be the digitalization partner for the operator. So that means that whenever an operator is working with us, we ensure that what we are getting paid for, it's lower than the turning back that they have because of the use of Savannah. So from the first day, we ensure that. And that's the way we build a long-term relationship, because from time to time, after we finish the contract or whatever, they can see that they have that payback from the beginning. So there is no initial investment actually.
Are there already customers that move from scheduled maintenance to full CBM?
Excuse me, how many customers?
Sorry, are there already customers that have moved from scheduled maintenance to full CBM?
Yeah. Nowadays we're working with two different customers that already did that. One of them did it for the whole thing. I mean, not infrastructure yet. They are working with our CBM for signaling, and our CBM with rolling stock, and another one just for rolling stock.
Another question asked by Laurie Murray: who is the biggest beneficiary by deploying this system?
Who is the biggest?
Who is the biggest beneficiary by deploying this system?
Well, it depends. Depends on the operator, because Sometimes it's the running stock maintenance department. Sometimes it's the signaling maintenance department. Sometimes it's the operator. The operator, because it's what Neil said. Okay, he really nailed that. I mean, by just monitoring things, you don't get any value. But sometimes, operators have value because of the information that they get, like how many people there's per car, how is the driving being done. It really depends on the operator. It really depends on the customer. We have one customer, for example, that we use Savannah to audit the driving, how the drivers drive the train, if they are late, if they have delay, if they cause hazard situations for the clients, that kind of stuff, because they're a concessionary, okay, so they get paid for the operation, and if the operation is bad, they get penalties, okay. So that's a turning bug that they have, okay. So a way to determine if the operation is bad, or the maintenance on the infrastructure is bad, it's to audit everything and have the data about what happened, and also activate that in order that to give formation to the drivers in order to fulfill the quality parameters. So it really depends a lot on the customer. Every customer needs to build its own business case.
Okay, so that's it for questions. So we'll draw it to a close there. Thank you again, Mark, for that presentation. And we'll now close this session and meet again in a couple of minutes for the next presentation on digitalization of rolling stock.